Hello everyone, myself Prasad. Today here with the new topic types of inversion and plume behavior of the year. So here we are going to discuss about the types of the inversion and the plume behavior. So starting with the types of inversion. So the first of all we are having temperature inversion. In this is a situation where the temperature increases with altitude, contrary to the usual decrease. In volcanic plumes, it can trap volcanic gases and aerosols below the inversion layer, potentially leading to health and environmental concerns. The next is the stable plume. When a plume is denser than the surrounding air, it tends to spread out horizontally, often staying close to the ground. So this is the stable plume. And this can lead to a rapid deposition of ash and other particles in the vicinity of the volcano. So the next is unstable plume. An unstable plume rises rapidly due to its buoyancy. Such plumes can ascend to great heights, disappearing ash and gases over vast areas. This can pose risks to aviation and have broader environmental impacts. And the next is mushroom or umbrella plume. Uh, this is a classic shape observed in large volcanic eruption. So this plume is usually seen during the volcanic eruption or during any blasting of the bombs and all. So that a huge amount of gases rises up. As the plume rises, it spreads out at the top, forming a mushroom or umbrella-like shape. So the next is we'll be looking towards the plume behavior. So plume behavior refers to the dynamics and characteristics of volcanic plumes as they rise and disperse in the atmosphere. So plume behavior is crucial for assessing volcanic hazards such as ash dispersal, gas emissions, and potential impacts on aviation and human health. So, so let us look towards the different plume behaviors. So the first one is the buoyant rise. The primary driving force for volcanic plumes is buoyancy. The hot volcanic gases and ash particles are less dense than the surrounding atmosphere, causing them to rise rapidly. This upward movement is influenced by the factor like the volume of magma erupted, gas content, and the wind conditions. So the next is jet plume. A volcanic jet refers to a high velocity focused on column or a volcanic material ejected directly from the vent. As it rises, a jet can transition into a broader plume, which spreads out due to atmospheric conditions. So, particle size and settling. The size of particles within a plume affects their behavior. Larger particles settle out more quickly, while fine ash can remain airborne to extended periods, traveling long distances. The settling velocity depends on the particle size, shape, and the density. So the next we are having is wind influence. So the atmospheric winds plays a critical role in the behavior of volcanic plumes. So wind can disperse a plume in different directions, affecting the distribution of ash and gases. Wind shear or changes in wind speed and direction with altitude can also influence plume structure. The next is plume collapse and pyroclastic flow. In some cases, the materials erupted from a volcano can become too dense and collapse back to the ground, forming pyroclastic flows. These fast-moving flows of hot gas, ash, and rock can travel at high speeds, posing significant hazards to areas around the volcano. The next is plume height and monitoring. Monitoring the height of volcanic plume is essential for assessing potential hazards. Satellite imagery, ground-based observations, and remote sensing techniques are used to estimate plume height and track its movement.